Yeah.
And then I lied to them. And said that I was trying to find the Beaver Island Trail.
Would you have the bike with you, or were you just walking?
No, I had the bike with me.
Walking on the golf course?
Well, I didn't know that it was a golf course. It was just a bunch of grass where I was.
Okay. All right, we're looking at,
No,
so
it's not
this
like that.
is, if you recall, this is what we learned yesterday, that if we wanna figure out, the area of a polar curve, we have to figure out this alpha and this beta, and then we just square R, and that R is some function of theta, okay? So, things to watch for when we have more than one polar curve. I already talked about points of intersection yesterday and symmetry. You can save yourself a lot of work. So, I'm going to, we've got these two equations, and what I did is I kind of graphed them so you can see what they are. And this one right here, so you could see that if I put 0 into here, R would be 0, and if I put pi over 2 into here, R would be 2. So this is going to give me a circle that looks like this. And this one, when R is 0, I get 4. So let's make this 4 here. So it's 2, 1. It's not going to be a graph that looks like. And so we're talking about this area right here. And so I'm going to blow that up. And it's going to look like this. And it's going to look like this. So this side of the equation is R equals 4 cosine theta. And this side of the equation is R equals 2 sine theta. Super. Are we okay with that? Okay. So if you look at this, right here, here's R. Okay. And it's this R, right? R equals 2 sine theta. And then once I get past this point, it changes, the R changes, doesn't it? Correct? So we're going to need 2 integrations. Does that make sense? Okay. So I have to figure out where that point of intersection is. And the way I'm going to do that, I could do it on my calculator, but sometimes you get asked not to do it on your calculator. It's, well, this one I did do on my calculator, and you'll see why. So I get 4 cosine theta equals 2 sine theta. And so I divided both sides by cosine and both sides by 2, and I got 2 equals sine of theta over cosine of theta. And so then I got 2 equals tangent theta. And so then I said, okay, what's the tangent inverse of 2? And you guys know how to save that, right? I showed you how to store that into something. Okay. And so that's what I did.
I don't know how to store stuff.
Oh, okay, I'll do it right now. And you have this calculator that was so nicely returned to me yesterday, and I did not acknowledge it appropriately. So I am saying so, and it's now going to be on the tube. Okay? Okay. Can you see this, Walker? Okay.
Yeah.
Okay.
Yeah.
So I'm going to go second tangent inverse. You get 2. So I want to store that whole thing, because if I store the whole thing, the less chance of error I'll have at the end, because I just want to know at the end. So you have a button that says STO with an arrow that points to the right, correct? So I'm going to go second answer. Okay, you got that? we hit that store button, and up here you have alpha. And I'm just going to make that, I'm gonna make it A. Alpha A. Okay? And if you notice, it repeats itself. So anytime I get alpha A,
Alright.
it's going to be that value. And it'll stay that value until I change it, okay?
Sorry.
Does that make sense?
Yeah.
All right. So I get tangent inverse to be approximately 1.107. So what I'm going to do is, when I put 0 in the sign, I get 0, correct? Would everybody agree with me? So that means I'm going to have 1/2, and I'm going to integrate from 0 to that point, which was 1.107. And I have 2 sine of theta, that's my r. I'm going to square that d theta. So once I'm beyond that 1.107 radians, my r now becomes this one, correct? Okay, and so I'm going to add to it 1/2. I'm going to have 1.107, and I'm going to have 4 cosine of theta squared d theta. And now I have to figure out when this comes to 0. So I'm going to look at this and say, all right, when does that come to 0? And if you take a look, when I take a look and it's moving across here, I'm talking about it starts at 4, moves, and it's getting smaller and smaller and smaller. And you can see once I get to pi over 2, this graph is going to be 0. In fact, when I put pi over 2 into here, r is going to be 4 times the cosine of pi over 2, that's going to be 0. So I'm going to integrate from this value to pi over 2. So there's my integral. Again, this is r when I'm on that, when I'm between 0 and 1.107 radians, and then this is my r when I'm between 1.107 radians and pi over 2. So that's how I set it up in my calculator. And I got an area. Did you do it already? I'll let you do it. Let's see if you did it right. Again, a thing you can, you can put this in your Y1 and Y2 if they have multiple questions. Hi, Brent.
How's it going? Did you get I was with Zasky, I don't know if you got a pass for
Yeah,
that.
I'll see him during lunch.
Sounds
I
good.
walk through, if I didn't get it, he'll say, yeah, he was, and everything will be cool. Now, your advantage to that is, that's a long time from now. And right now, I gotta make sure I remember to give Lucy what she needs,
Sounds good to me.
and so I may not even ask. I'm the safest person to give any secret to. Are we okay with that? Where'd you get? Oh, we don't have it yet. Did it start with a 0 and a point? I think it does. Lucy, did you get one?
I did, I hope it's right. I got,
Is 9 the next digit?
it's definitely not.
Oh.
Oh, so. I got 9 as the next digit.
Yeah,
I got
I
nine.
got 9.
Whoops.
And then, did you get another number divisible by 3?
Yes.
Yes.
Is that number 6?
Yeah.
Or what I like to call an upside down 9?
Yeah.
Okay. And then a 2,
Yeah. Yes.
notice, divisible by 3, divisible by 3, 3 times 2, 6. 3 squared, 9, it's just all there all the time. Alrighty,
That looks horrible, I feel so bad.
Are you in
for that.
radians?
Yeah. I'll just redo it. I probably did 6 or
Okay.
polar.
That's criminal.
What?
I don't think you have to do it in polar. I think you can do it in rectangular as long as you're integrating in radians. I think you're okay.
Then I can't help you, I'm sorry. Okay.
All right, so now we're talking about, here, this equation right here is r equals 2. So here you have a center, you don't care what theta is, and as theta change, you're just going 2 units out all the time. And this cardioid is r equals 2 minus 2 sine theta. And so we're talking about the area that's in between both of those, find the area in the common region. And so this is the area that's shaded. Excuse me. So you can see that it's symmetrical, correct? Excuse me. So what I'm going to do is I'm going to figure out the area of this region right here. And just multiply it by 2, okay? So I'm gonna have, this is how I'm gonna start. I'm gonna have 2 times 1/2. And if you take a look, I'm gonna start here and move counterclockwise. So if I start here and move counterclockwise, what's that angle measurement? Pardon? Pardon? I can't hear.
3 pi over 2.
Okay, it is 3 pi over 2. Now, if I do 3 pi over 2, that means, and I start with 3 pi over 2, it's gonna come in this direction.
Negative pi over 2?
I'm gonna use negative pi over 2, okay? And I'm gonna go from negative pi over 2 and I'm gonna stop here because once I get beyond this angle measurement, my R changes, correct? So if I'm going from a negative pi over 2, what's my beta?
0.
0, perfect. And so again, that's, R is equal to 2, so it's simply 2 squared d theta. And you could say, hey, I already know what that value is. It's a quarter of the area of that circle, right? So you almost can skip this part, right? You could do it by hand, say, hey, I have a radius of 2, so the whole thing would be 4 pi, 1/4 of that would be pi, correct? Plus, again, I'm gonna have a half. And I'm gonna go from 0, because I ended at 0, and it's this portion. So if you take a look, I'm using R is equal to 2 minus 2 sine theta. So when I put 0 in here and start at 0, I'm going to have 2 minus 0. Sure enough, I'm at 2 units out. And when I get to pi over 2, sine is going to be 1. 2 times 1 is 2. 2 minus 2 is 0. So I want to go to pi over 2. And then it's going to be 2 minus 2 sine of theta squared d theta. Now, my guess is when you put it in your calculator, you'll only do this portion plus this portion, because since you're doubling it, the halves are gone, correct? Okay. Does that make sense,
Yeah.
Ethan? Okay. And what do we get with this one? So here you have your next two graphs. You have, so this right here is the equation r equals negative 6 cosine theta. That's this one right here. So when you go to 0, normally you get 1, but when you multiply by a negative 6, rather than going to the right, it's going to go to the left. Okay? And so that's why you have this big circle right here. And then you have this inner cardioid right here, and this is going to be r equals 2 minus 2 cosine theta. Again, when I'm at 0, I'll have 2 minus 2, which is 0. And so the region that's common to both of them is this region. And again, I am just going to figure out the area of the top half and multiply it by 2. And I'm going to have to, if you notice, Brandon, I don't know if you were here when I was talking about this, but this portion right here is this R. Okay, this portion right here. So when I go from the origin to here, I'm going up to this equation. And then once I get past that point, then I'm doing this cardioid equation, this R. Does that make sense?
Yeah.
You can see that?
Yeah.
Here, 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 but once I get this point, then that's gonna be my line, okay? All right, so what I'm gonna do is I'm gonna make them equal to each other to figure out that intersection point. And I got, let's see, negative 2 equals 4 cosine theta, negative 1/2 equals cosine theta. So I believe that means theta is equal to 2 pi over 3. I think we had that discussion yesterday, you and I, didn't we? I'm sure that discussion was branded into some brain cell. You know what a brand is, like the new kettle? My guess is you'll never forget that it goes in negative 2 pi over 3 is a negative 1. Mine is. See? All right, we're getting off task here. All righty. So, here's my equation. Area is equal to, now I'm doubling it, so I'm going to get rid of the half. Now, I'm starting here, correct? So that is at 0 to 2 pi over 3. Does everybody understand why it's at 0? Because when I put 0 in here, I get 2 minus 2 and got 0. Excuse me, when I put 0 in here, I get this. I don't want it to be 0. I want it to be pi over 2. Yeah, pi over 2. How'd you come up with pi over 2? Because I'm doing this, correct? And when I put pi over 2 into there, cosine of pi over 2 is 0. 0 times a negative 6 is 0. So it's got to be pi over 2, and then 2 pi over 3. And it's going to be a negative 6 cosine of theta, that thing squared d theta. And then I'm going to go from 2 pi over 3, and I got to figure out when this one becomes 1, 2, 3, 4. Well, that's at what? So what would that be? What would that angle measurement be? Pi. And let's check. 2 times pi is a negative 1, so So I'd have 2 times a negative 1, which is a negative 2. 2 minus a negative 2 is 4. You're right, it's pi. And that's going to be 2 minus 2 cosine theta squared d theta. What did you get to that? Does it start with a 1? Then a 5? Does it start with 15?
Yes.
And then a 7? And then a 0? And then an 8? All right, the other example you get is when you have an area that's bounded between two of them. So if you remember when we did it in rectangular, here's an empty space, right? It's empty. And so that's going to be taken away. And so we have a big R that goes from the origin all the way to this R, and we're going to call that R2. I think I called it big R before in rectangular, but we're going to call that R2. And then this part of this empty space, we're going to call R1. So the area is going to be 1/2 the integral from alpha to beta of R2 squared d theta minus 1/2 from alpha to beta of R1 squared d theta. I use it in this form, 1/2 alpha to beta R squared R2 squared minus R1 squared d theta. That's the form I always use right there. Okay? I feel like I'm going too fast. Okay, backside. There's a name for this. This is called a crescent. So here's my R2. Here's my R1. So again, I'm going to double it. So I'm going to leave off the half. And if I'm at 0, this R2 is going to be 1, R equals 1, correct? Because if you take a look, it's 1 all the way along here. Right? So this is going to be R2 equals 1. So I'm going to have 1 squared. And I'm going to go from 0. Now, it's going to end up being right here, correct? So that's going to be pi over 2. And it's going to be minus, parentheses, 1 minus cosine theta squared d theta. So R2 is equal to 1. R1 is equal to 1 minus cosine theta. And so when I made them equal to each other, I'm going to get cosine theta is equal to 0, and theta has to be pi over 2. that's where the units are. And so I get an area of approximately how much?
1.215.
One what?
1.215.
That's what I have too.